So next up is Andreas. Please take it away.
Thank you. Good morning, everyone. So yeah, now we're changing things up a bit with a very technical talk after Alex's talk just now. Yeah, my name is Andreas. I work at Tweak, where I lead the Scalable Builds group. And today I'm going to talk about our experience in migrating dependency management to bzlmod and our rule sets. And in the spirit of being an imposter, bzlmod is still very new. So, you know, take the things I'm presenting with a grain of salt, but this is what we've arrived at so far. So to give a little bit of orientation, I'm talking about dependencies. And more specifically, I'm talking about external dependencies. So any kinds of dependencies that are not part of your source tree. And why would we care about these things? Well, because as engineers, we don't like to reinvent the wheel, right? We want to use the things that others have written already. So pull those into our project. So how can we get our hands on these external dependencies in Bazel? The old way that many of you will be familiar with, of course, is the WORKSPACE file, which is one single file at the root of your project. And in that file, you declare any kinds of external dependencies, like other rule sets that you might depend on, or package manager dependencies, or tool chains, or the like. So let me give you an example. So let's say we are the root module indicated by that little circle there. And let's say we are a Haskell project and we depend on rules Haskell. And so to get rules Haskell into our Bazel project, which is like rules Haskell is a Bazel extension to build Haskell code, we would write into our workspace an HTTP archive invocation like this that downloads rules Haskell and places it into this repo called rules Haskell. Okay, fine, but there is a problem. We depend on rules Haskell, but rules Haskell itself also has dependencies. For example, it might depend on Skylib. So how do we get Skylib? With this workspace mechanism, this is not actually captured automatically. So transitive dependencies are not taken care of here. The solution that people came up with, of course, are dependency macros. So rules Haskell exposes a macro that you can import and then invoke, and then that is going to import Skylib. But it's not really a pretty solution, because what if Skylib itself also has dependencies? Then the whole thing just gets a bit messy. And there is another problem. So to talk about that, let's shorten this import a little bit so we have a bit more space on the slides. So let's consider this duplicate import. We're importing rules Haskell twice, once at version 15 and once at 16. Which one wins? Raise your hand if you think it's the first one. Okay, that's a small number of hands. Yeah, in this case, it's going to be the last one. So the majority is right here. Okay, let's change it up a little bit. Let's put those load statements in between here. What happens now? Which one wins? Do you raise your hand if you think it's the last? Okay, most people here are right, yeah. So now it's going to be the first, because Bazel has to realize this thing to make the load work. But the problem I'm trying to illustrate with this is that workspace semantics are imperative, sequential, and subtle. So subtle is always great in software. And this gets worse. So let's consider an example in the abstract. Let's say we're the root module again as this dot. And we depend on rules Haskell. And rules Haskell depends on Skylib at version 1.1.1. But we also depend on rules Nix packages, a Bazel extension to import Nix packages. And that depends on Skylib version 1.03. Which version of Skylib are we going to get in our project? It really depends. It depends which dependency macro do you invoke first. Does it do override checks or not? So this causes what you could call spooky action at a distance from time to time. So if you make an update to one of your dependencies or you reorder your imports, you might get very surprising consequences on some seemingly completely unrelated dependency. So to summarize the problems with the workspace approach, it does not resolve transitive dependencies for us. We need dependency macros to handle those. It is imperative, sequential, with subtle semantics, and the ordering matters. And it's also somewhat opaque. It's quite difficult to actually figure out where a particular external repo came from. And we get this spooky action at a distance problem. All right. So the Bazel team recognized the problem and introduced a new dependency management system called bzlmod. And this is a new dependency manager for Bazel. And you can take a look at the BazelCon 21 talk by Shudong and Yoon to learn more about it. And the way this looks in your code base is you're going to have a module.bazel file. And in this module.bazel file, you're going to list your direct dependencies. It's declarative. There are no macros or anything that go crazy, at least so far. Let's see where we'll go with this. And then if rules Haskell itself has dependencies, then it only declares its direct dependencies in its module.bazel file, and bzlmod is going to resolve the thing transitively for us. And there's also tooling to inspect it, like with bzlmod graph, for example, so the whole thing is transparent and there are no more surprises. All right, so we're talking about external dependencies, but more specifically, I want to talk about package managed dependencies. So what do I mean by those? So far, we've been talking about Bazel modules like rules Haskell, Skylib, and so on. Anything that's a Bazel project itself has a module.bazel file. But with package manager dependencies, I mean things like packages you import from Maven or packages you import from NPM, anything really that relies on an external package ecosystem. And why do we care about those? Well, again, we don't want to reinvent the wheel. Those package managers already exist and those ecosystems are established. Why rewrite them in bzlmod or Bazel all over again? Okay, so I'm going to start to tell about how we work with this in the Haskell ecosystem with rules Haskell. And at first, I'll give a very brief and simplified overview over the Haskell package ecosystem. Those familiar with it, please bear with me. It's going to be greatly simplified. So in Haskell, we have things that we would call packages, like file path, for example, to deal with file paths, or JSON to serialize, deserialize JSON, or tasty to do unit testing, and so on. And then we have a thing called stackage, and stackage is a curated set of are snapshots that are a curated set of versions of packages that are known to be compatible with each other. And then there is a package manager called stack that you use to resolve the dependencies within such a snapshot and then download those packages and manage them. And the workspace integration we had in rules Haskell so far looks like this, where in your workspace file, you would invoke the stack snapshot repository rule. You would give it a name that defines the name of the repo to be generated. You give it a list of packages that you directly depend on, and then it will use the stack package manager to potentially resolve transitive dependencies. These will be exposed under labels in the stackage repo. And then you have an attribute to define which particular stackage snapshot you want. Those are like long-term support versioned snapshots. So this is just some number. And if you want to learn more details, in 2019, I gave a talk about this at BazelCon. So what's the problem with this approach? Let's consider an example. And as an example project, I'm going to walk through a Gazelle extension of ours to generate build files for Haskell packages. And this project is called Gazelle Cabal. And Gazelle Cabal itself has a few Haskell dependencies. For example, it depends on the file path and the JSON packages. So it invokes stack snapshot like this to get those in. Now let's consider a case where we are the root project. We depend on the Haskell package tasty for unit testing, but we also depend on the Bazel module Gazelle Cabal. But now we have a problem because Gazelle Cabal depends on file path and JSON, but we didn't import those in our workspace file. So they're going to be missing for Gazelle. So what we have to do instead is that we have to pull those transitive dependencies actually into our workspace file and import them there as well so that they're available. So again, the problem here is that the workspace mechanism does not offer transitive dependency resolution. So how does this work in bzlmod? Well, what we want is transitive dependency resolution, and we get that with bzlmod. So in that case, the root module is just going to declare, I depend on tasty. Gazelle Cabal is going to declare, I depend on file path and JSON. And then bzlmod is going to resolve all those transitive dependencies for us. So how could it possibly do that? How can bzlmod know about Haskell at all? So bzlmod is extensible with module extensions. And the way you use those is that in your module file, you would first import this extension with a use extension stanza. Give it a name. For brevity, I just call it stack here. And then you invoke those members of it, which we call tags. So here we say that our module uses the stack package tag with the name attribute tasty. And this says my module depends on the Haskell package tasty. And then this module extension is going to do some stuff and generate some repos, and we need to expose those repos if we want to use them. So there is a use repo stanza we have to put into our module.bazel file to actually get access to those package labels again. And we did it so that the labels stay the same, so the migration should be easy in your build files. And then if you are a module author and you want to write a module extension, then the way you can do this is very similar to how you would write a rule or a repo rule. There is a module extension built-in that you invoke. You give it an implementation function and then the list of tags that you're going to support. These tags are also defined with a built-in tag class where you set the attributes, and those attributes are very similar to the kinds of attributes you get on rules and repo rules. And then the implementation function also takes a context object similar to rules and so on. And you can iterate through all the modules that invoked your module extension in breadth first search order, starting at the root. And then you can iterate through all the tags that that module requested from your module extension. So how can we actually import packages then, since this is the goal after all? Module extensions have a couple of capabilities. They can perform arbitrary actions like download and execute, and they can invoke other repository rules. Unfortunately, we already had a stack snapshot repo rule, so we can just invoke that in our module extension. Okay, so how do we migrate the repository rule API to the module extension API? Let's first consider the package list attribute. The way we translated this is that instead of having a list attribute, we have individual tags for each package that you depend on. And the idea here is that thanks to this, you're going to be able to declaratively describe your direct dependencies. And you can do this across the module dependency graph so that you get the transitive dependency resolution. So that's the idea behind moving this list into individual attributes. Then we have the snapshot attribute, which would define which snapshot release we want to use. And that we also just turn into a tag. But there is a bit of a problem here. There's something lurking that we need to be careful about. So let's consider the case where we had the root and the Gazelle Cabal module. What if root wants snapshot 2114 and Gazelle Cabal wants a different snapshot 2012, for example? Which version should win, right? So what we do here is we disregard the intermediate one and we use the root one. And again, this comes back to those spooky actions at a distance. We want to avoid that some intermediate dependency update mixes up our build in the end unexpectedly. So we only look at the root module or the core module, rules Haskell itself, and disregard things in between for these kinds of changes. Then there is a more complicated case, which was an attribute that is of dictionary type, to pass flags to packages. So Haskell packages can be configured with flags. And the way we translated this was that instead of keying on the package name and then giving a list of flags, we just fold this into the package tag directly because, you know, that's where it belongs. But again, there is this problem lurking. So let's say we want vanilla JSON, but Gazelle Cabal wants JSON with the -pretty flag applied. Which version should win? To avoid the spooky action, again, we disallow this in the intermediate ones. In some cases, maybe you could consider to kind of resolve those globally. I think this depends on the package ecosystem, what makes sense. All right, this part concludes Haskell, and now I want to take a look at rules NIX packages. And to give a really brief overview over what NIX is, in NIX we have packages, think like Linux distribution type packages, like compiler tool chains, system libraries, system tools. And then we have a thing called NIX-PKGS, which is a very large collection of packages. It's really just a Git repository. What it contains is pinned version, the dependencies between those packages and their build recipes in code in this repository. And it's available in multiple release channels. There are stable releases and there's an unstable channel you can follow. And NIX itself is also a flexible language that allows you to do ad hoc overrides of packages, or even come up with ad hoc completely new packages if you want to. And you can also learn more about this at last year's BazelCon talk. So what did the Workspace integration look like so far? We had one set of repository rules to import NIX packages repositories, and then another repository rule to, or set of repository rules to import packages. So for example, if you want to import the NIX-PKGS repo at a stable version, then you would, for example, download it over HTTP like this. And if you give it the name NIX-PKGS, this is sort of the standard repo. And then if you want to have a package like GNU-awk, for example, then you could just say this, and this would look for a NIX-PKGS repo in your project and would then import from there. Or if you have a use case where you want to do a custom override, version override, or something like this, you could, for example, get an unstable NIX packages repo and then specify that with a repository attribute that you want to have the package from there. And you can also give it a different name if you want to do this. Or I mentioned Nix is a flexible language that allows you to do overrides or custom packages. So in this case, we're saying, I want the GNU awk package, but I'm going to use the Nix language to actually include a couple awk extensions to support CSV and JSON support in the language. So you can also do these kinds of ad hoc overrides. So how can we manage to migrate these kinds of things to the bzlmod module extension framework? So let's first consider this in the abstract. Let's say we have our root module, and that sets nix.pkgs revision 2305 and imports awk. We have module A, which uses a different nix packages revision and also imports awk. Which version should win? You're going to see a pattern here. We're going to cross out the one at module A and going to stick to the root module or core module definition. Similarly, if root is asked before, but mod B does an unstable override and wants to set awk as an unstable version, which version of awk should win globally? In this case, also, we avoid the spooky action and cross this out and say the root version wins. And what does this look like in code? You import the module extension nix repo for repositories. You say, I just want sort of the globally resolved nix.pkgs repo version. And you import the repo to get access to the label. And if you want to do an override, there are override tags. So you can say in your project, I actually want a different version like 2305. And then you use the HTTP tag, for example, to download that. But that is only allowed in the root or core module. And for a package, it's much the same story. It's called nix.pkg. And you can say, I want the awk package as it is sort of globally resolved. And then import the repo to get access to the label for it. And if you want to override it, you can use one of the override tags, like expression, for example, to pass in this custom Nix expression to override the CSV and JSON extensions. But this is also only allowed in the root and core module. But what if we have a case where module B really needs this unstable version, perhaps because it has a particular rule that depends on some particular bug fix or something like this. Or maybe module C really needs this custom override feature because it maybe has a gen rule that does the JSON CSV thing or something like this. How can we allow this in some specific cases, but still avoid the spooky action where root all of a sudden gets a different version of awk than it expected? Fortunately, Bazel just introduced a new feature for module extensions, which is isolated module extensions. And what this means is that module B and C can stick to their respective overrides, while the rest of the project gets the sort of globally resolved default behavior. And the way you can do this is when you import the module extension, you set the isolate parameter to true to mark it as isolated. And then if the module extension is implemented this way, it can allow you to do things in a non-root or core module that you would otherwise only be allowed to do in root or core. And finally, again, you import the generated repo to get access to the label. And this is available as of Bazel 6.3 with this flag experimental isolated extension usage. And then if you are an extension author, the way you implement this is that you check the isolated attribute. I'm doing this here with getAttr for backwards compatibility since it's experimental still. And then you can decide what logic you want to apply to decide whether overrides should be allowed in your module extension. All right. Finally, I want to do a brief note on use repo stanzas. So use repo stanzas in the module.bazel file. We've seen a bunch of them. They are necessary to get access to the repos that are generated by the module extensions. I won't go into the details of this, but it can be seen as a bit of a maintenance burden. You end up having to duplicate things in your module.bazel file. You have to invoke the package tags, for example, but you also have to invoke use repo in the module.bazel file to get those repos imported. And fortunately, there is bulldozer automation support. So for example, if we go ahead and comment out the awk import here, and then run a Bazel command, like bzlmod graph, for example, then Bazel is going to print out a bulldozer command line, and if we execute it, it's going to fix up the module.bazel file for us. But to support this, your module extension has to do some work. In particular, it has to return the extension metadata object that you can create like this. And you can take a look at this proposal, automatic use repo fixups, if you're curious for more details. And for those of you who are familiar with hub repositories, I think with automatic use repo and isolated module extension instances, there's probably no more need for hub repos in most cases. I'd be curious to hear what your thoughts are on this. But yeah, if you haven't heard of hub repos before, then don't worry about it. All right, in conclusion, what we covered the tenets of bzlmod. It is declarative. You declare your direct dependencies. Transitive dependencies are resolved for you. We have no more surprises, and we avoid the spooky action at a distance. To migrate your repository rules to module extensions, you can map your repo rule attributes to tags. You can try to make it so that the labels that are generated are the same as under the repo rule, so that the migration is easier on the build file side. And then you can consider what kinds of things should be allowed globally, what should be restricted to the root or the core module, what should be allowed in isolated extensions. And then make use of the automation, return extension metadata from your module extensions, and make use of bulldozer automation to manage those imports. There's a whole lot more to module extensions that we didn't have time to cover. For example, we didn't talk about toolchains. We didn't talk about testing module extensions or Bazel modules. We didn't talk about how to release on the Bazel Central Registry, for example. If you're interested in these kinds of things, come talk to me or many of the other people familiar with this in the room. Or join our Bazel Hour on November 2nd, an online meetup where we talk about migrating to bzlmod. And finally, a few words about my employer. I work at Tweak, where I lead the Scalable Builds group. We contribute to open source build systems like Bazel, Bug2, and so on. And we help our clients with their build system migrations, optimization. So if you have build system issues, then come talk to us. Check out our page. And Tweak is also part of a larger platform called Modus Create that does platform modernization, DevOps, security, and other such things. All right, thank you very much. And yeah, maybe we have a bit of time for questions.
Hey, thanks. Great talk. So as a monorepo maintainer, something we get asked a lot is how can I get like some project want to use some dependency on some version while the rest are using the rest of the versions. So I was wondering if the isolating option could in a way be used for this, other than creating another repo?
Yeah, that's a good question. So the question is on the recording, but yeah, so in principle, potentially that could be done for this. Something to consider is if you're talking about third-party packages like Maven imports or the like, then if you use the isolated module extension, isolated module extensions are isolated, meaning they don't see anything of any of the other instances, including the global one. So you're not going to get any sharing between those. So if you do this, then you are going to duplicate a subset of your transitive package dependency graph from this. And this potentially exposes you to the diamond dependency problem, right? If you have some target that depends on this part, and then you have overlap, you might expect some bad things. So one of the reasons why we support this here in the Nix packages use case is that with Nix packages, something you very often import are tools, executables. You rarely link them together. You typically use them in a build action or something like this to generate some files. And of course, there are also like API constraints potentially, but it's much less risky in terms of diamond dependency problem. So yeah, I would wield that with very much care. Other questions?
Yeah, I was wondering if you're aware of any plans, because I think the Bazel mod file might grow very large. But I think so far there's no way to import macros from other Bazel files.
Yeah, so I mean, I'm not one of the developers working on the module.bazel support, but yeah, this has been discussed, how to split up the module.bazel file, because it can become a bit of a choke point when it comes to code review and merges and so on. I mean, I think we should just be very careful, whatever we do there, to avoid making the same mistakes that ended up being the case in the WORKSPACE mechanism. And yeah, this is something that needs to be worked out. Yeah.
Yeah. So basically, currently we have two ideas. One is to support import statement, so you can basically add the content of another module.bazel file to the same file, and we just report error as if it's the same in the same file. The other one is to allow import BZL file from the same repository. so you don't node from any other external repo, but that should help with the maintenance and avoid the spooky problem. Yeah, but please join the BOF session if you want to learn more.
Other questions?
So on the Haskell side, you said that you are going to resolve to the newer LTS, to the one in the root, but sometimes packages get dropped from LTS when you move to the next one because incompatibility with JC and so on. So what would happen if Bazel would depend on a dependency that is now dropped on the new LTS?
Yeah, that's also a good question. So in those cases, the root module would have to provide some kind of fix for this. So one thing could be is maybe could update to a different snapshot version. Something that's supported with a package management system is that you can have local custom snapshot where you sort of add additional packages. With the integration, you're also able to just import a particular package release directly from Hackage. You do this by just appending the version. Or you can also include sort of Bazel built vendored overrides. So yeah, that would be the answer. In the root module, then fix this up. Yep.
Any other questions? Yes.
Your concern about disallowing the spooky action at a distance, that is your decision, or it is something that the bzlmod extension mechanism itself encourages or requires?
So I'm not sure if I read it in the docs anywhere. It's just something that in the workspace mechanism we have experienced a number of times and wasted many, many cycles on trying to debug these kinds of surprising changes when we did a completely unrelated update or import order change, or clients that ran into those issues and then came to us with very confusing behavior and said, what's going on here? And so we just want to avoid putting the same kinds of traps into this new mechanism. And I think it would be a good thing to try to strive for with Bazel module extensions, but I don't know if there's sort of a general recommendation for this in the bzlmod world.
So we basically, the extension API is structured in such a way that it allows you to basically anything. It gives you all the access to the data across the dependency graph. So you could do something like rules Haskell / Nix PKGS, where you say only the root module is supposed to do something. Or for some other package managers, maybe it makes sense for you to say, I can actually smartly merge all your requirements. So it's not spooky action at a distance, it's just action at a distance. That is easily understandable or clearly described or whatever, depending on the ecosystem you're in.
Yeah, and I mean, some sort of transitive resolution also happens here with the transitive package dependencies. They're going to add new transitive dependencies into your build graph. So you are going to see some effects, like longer build times, for example. But we were just striving for not messing up the configuration of the build that the root module expects. Yep.
Maybe one more question. For a great talk, Andreas.
Thank you.